Hello everyone, and welcome to the investigation of the Terminantz Pesticide Corporation explosion. Let's introduce a victim affected by this horrific event. This is Flick. He's just your average six-legged ant living his best life. He's got 2 kids, a nice apartment on the anthill, and a pet rock named Pebbles. But Flick's life would be forever changed on the morning of May 19th, 2018, due to an accident at the local Terminantz pesticide plant. That evening, he would return to his anthill from a business trip to find his entire ant colony dead. Let's take a look at what caused this horrific 100% fatality rate. The Terminantz pesticide plant is located around Lubbock, Texas. Pesticides are produced from toxic chemicals such as phosgene and ammonia, so many hazards can be present in the production facility. It was 2 a.m. at the plant when a crack formed in a pipe carrying cooling water. Water began leaking from the line and a puddle formed. The puddle was quickly detected when a worker slipped on the water and injured his head during the fall.
Before we move on, let's take a look at the workplace hazards present. First, the puddle is a slip, trip, fall hazard and should have been reported immediately. All chemical production plants should be working consistently to identify workplace hazards before they cause injury. Most importantly is checking the compatibility between the fluid components and the pipe and tank material. Operators should attend routine training for hazard identification in the workplace. Second, bless his heart, the poor operator should have been wearing a hard hat. Proper PPE for chemical processing plants should include a hard hat, gloves, steel-toed boots, earplugs, and safety glasses. All workers are expected to wear required PPE anytime they are working at the plant. And third, routine safety checks should be performed to assess equipment health. Safety checks help detect potential equipment failure before it occurs, and if done in this scenario, could have kept the water pipe from wearing away.
Meanwhile, in the control room, operators were alerted to the pipe leak in the water cooling unit and attempted to shut the valve to the line so the pipe could be repaired. However, they accidentally shut the relief valve to the water heating unit instead of the water cooling unit. A pressure alarm began to sound on the water heating control panel, but of course operators couldn't think of any reason for it to be going off, so they decided to ignore the alarm and turn it off because they assumed the correct valve was closed. With the noisy alarm off, they could finally get back to watching TV on their phones.
Whoa, wait a minute. Let's talk about what went wrong in this situation and what should have happened. First, the valve shutoffs were mislabeled, causing the operators to close the heating valve instead of the cooling valve. Proper labeling of equipment is a necessary component of industrial safety and can easily prevent careless incidents. Second, the operators ignored the alarms, deciding to turn them off without proper authorization and neglected their responsibilities due to distractions they had made for themselves. Detectors and alarms are in place for a reason. An alarm should only be turned off after its source has been checked and verified. In addition, the actions of the operators indicates poor training and a lack of awareness. Operators should consistently and routinely be trained so they are prepared to handle incidents that may arise in the plant. They are also expected to be engaged in the events taking place on site so they can respond to issues quickly. In this incident at the pesticide plant, the operators should have been properly trained to notify a supervisor or engineer about the alarm and wait for further instruction before closing valves and turning off alerts.
Now let's take a look at what's happening at the site of the closed relief valve on the water heating unit. With the relief valve closed, the fluid in the water heating unit had nowhere to go. This caused the fluid to vaporize, which resulted in increased temperatures and pressures. At a certain point, all the liquid in the tank instantaneously flashed. The vessel ruptured and triggered an explosion. Oh my god. Unfortunately, Flick's anthill was only 10 meters away from the water heater. The resulting explosion killed his family, destroyed his community, and left his life in ruin. But on the bright side, his pet rock Pebbles did survive.
Obviously, there are many things that could have gone differently in this situation. First, all of the equipment should have been designed with alternative safety measures. In this scenario, the water heater should have had a backup plan in case the relief valve failed. Having safety measures in place for equipment significantly reduces the risk of catastrophic error. Proper mitigation strategies, such as a secondary pressure relief valve, could have prevented the explosion. In addition, it is important to ensure all the equipment design and storage heuristics are satisfied. For many tanks and vessels, there are liquid-to-vapor ratios which must be maintained inside the vessel in order to prevent catastrophic explosion. Safety rules, regulations, and procedures are put in place to maintain the welfare of everyone. It is important to understand the various properties of stored materials such as boiling points and heat capacity. As demonstrated at the pesticide plant, even water, which is a seemingly safe material at STP, can become extremely dangerous when handled incorrectly. Chemical plants should be constructed a safe distance away from communities, and communities should have pre-established evacuation and response plans in case anything dangerous occurs at the chemical plant.
Upon completion of this incident investigation, we have determined that there are several steps that Terminantz pesticide should have taken to prevent this accident. A significant part of process safety management is hazard identification and assessment, and all chemical plants should perform rigorous and routine analysis of facility hazards. There are 4 major questions Terminantz should have asked long before the incident occurred.
Question 1. What are hazards?
Hazards can include anything from toxic materials to equipment placement and spacing. They are generally identified through hazard checklists, surveys, or reviews.
Question 2. What can go wrong and how?
Great question. Asking this question prior to the incident could have actually prevented all the issues that propagated the events leading up to the explosion that took place inside the pesticide plant. One method used to assess failures is event tree analysis, which predicts all the possible outcomes of initiating event.
Question 3. What are the chances?
Process safety seeks to keep the chances of failure and injury as low as possible. EPA and OSHA guidelines tend to set conservative limits in order to maximize safety and minimize risk.
And question 4. What are the consequences?
Consequences vary based on the nature of the hazard and incident. Consequences can include anything from equipment damage to loss of life. Unfortunately, in the case of Terminantz pesticides, the loss of many ant lives was the consequence.
Ultimately, the goal of hazard identification and assessment is to generate inherently safer designs and processes and equipment that will permanently eliminate and reduce hazards. Fun fact, did you know working at a chemical plant is safer than being at home according to the fatal accident rate, or FAR for short?
In conclusion, chemical process safety is important to everyone and everything in the community. As you have seen, failure to follow safe operating procedures can injure workers, damage property, and ruin communities such as Flick's.
Don't feel too bad for Flick though. His life can't get much worse.
And on that note, thank you for watching our process safety video. Now let's take a second to acknowledge all the people that contributed to the production of this video.